All right, welcome to logarithmic functions. In this video, we're very briefly going to be talking about what a logarithmic function is as compared to exponential. So logarithms are the inverse of exponential functions. Hopefully you are very familiar with exponentials. In exponentials, you often saw things like this. If my money doubles every year, how much will I have after 3 years? Okay, good question. I've got an amount of time, I'm looking for the end. A logarithmic function, however, says this. If my money doubles every year, how many years will it take to reach $1,000? So it's sort of like, how long is it going to take for me to get to this point? Or this is the answer. Tell me the missing piece that I'm looking for. All logarithmic functions can be written as exponential functions and vice versa, okay? There's 3 pieces that are happening here. You have the base of your exponential, and that matches up with this little subscript number down here, okay? So in our first one, the way that you would actually read this is you would say log base 2. And we'll get in later into what the term base means, what that all looks like. But log base 2, that matches up with the fact that here in our exponential, 2 is the base, right? Those terms sort of match up with one another. Then we have in our exponential question, we had the exponents. So the cube, the squared, the 4, and the 9. Think back to the sample question. If my money doubles every year, how much will I have after 3 years? Okay, and then we got the answer. In this case, it was 8. Log works backwards. The exponent of the exponential function is the answer. That's what you're looking to find, okay? Or sorry, yeah, that's the answer to your question for your log. It's the information you're looking to find is what is the exponent? If the answer is 8, and notice where the 8 goes. So in this first question, it would actually say log base 2 of 8. So it said my base is 2, my answer is 8. What is the exponent that gets me there? In this case, the answer is 3. My base is 5. My answer is 25. What is the exponent on 5 that gets me to 25? The answer is 2. My base is 10. The answer is 1,000. Sorry, 10,000. Another 0 there. What's the exponent that's going to get me there? The answer is 4. And then we can see how it matches up when you've got to have variables. My base is x, my answer is 9, or my exponent is 9. The last piece of the puzzle is the 20. So you can see how things match up, okay? Now, common logarithms, the ones that we are primarily going to be working with, all have a base of 10. So for example, log base 10 of, this is 100,000, okay? Now, when they have a base of 10, you actually don't need to write the 10. It's just assumed. So you could just write log of 100,000, and that would be it. And you would assume that the base, if I were to do this in really light, presumed base 10. Okay, that's there. Let's do a quick question. Let's see if you're comfortable with it. Okay, if I have log base 2 of 128, this question is asking 2 to the power of what is 128. Okay. How would you get that? I'm literally just going to take 128 and divide by 2's until I get 1. So my answer is 7. And I double check. 2 to the power of 7 is 128. All right, that's the gist of logarithms and what they are.